a right angled triangle and told to solve for y when there's only an angle known and a length known? Well, what is there to do? There's kind of two major steps to this. The way how I kind of think of it is when we're given a triangle and we have an angle and a side, right? We have an angle and a side, and we need to find another side, we have to use sine, cos, tan, but not in the way that you think, right? So firstly, let's state the sides. So the 90-degree angle directly across from that is called a hypotenuse. Directly across our known angle is called the opposite, and whatever is left is called adjacent. So let's just look at this angle, okay? We know what the angle is, okay? There's no point in doing sine, cos, tan as we normally do and find the inverse and whatever, because we already do know it, okay? But looking at this angle, it's made up of two sides, this side and this side. Note how this side, y, does not touch the angle, because this is a separate angle, that would be there, right? And this side touches this angle, but no. This degree, okay, 35 degrees, touches the adjacent and the hypotenuse. So, adjacent all over hypotenuse, what is that? Sine, cos, or tan? Well, it's cos, right? So, we know what cos is, okay, because it's 35 degrees. We know what cosine is, 35 degrees. We know what hypotenuse is. We don't know what adjacent is. So, we're solving. This is algebra, okay? So, cosine of 35 degrees, we know what it is, okay? We're going to state that. Is equal to adjacent, I'm just going to state it again, just inverse, so y'all can kind of see it from different ways. So, cosine of 35, so adjacent, we don't know. We're going to have to solve for that. I'm going to leave it as x. Hypotenuse we know, which is 12. Okay, we need x on its own. So I'm going to bring 12 to the other side. So it's going to be cosine of 35 degrees multiplying by 12. Now, if you put this into your calculator, not inversing the cosine, just putting cos as it is, just press cos, 35 degrees multiplying by 12, and what are you going to get? You're going to get x is equal to 9.8. Wait, it's centimeters, okay? So 9.8 centimeters. So we know what the value of x is, 9.8 centimeters, right? And we couldn't have done this method of like using sine, cos, and tan to solve for a side, because y is irrelevant to this angle. Do you know what I mean? Like, it's completely opposite to it. We have one unknown side in this case, and we have to find y. So what would we do? Well, Pythagoras. We have two known sides, 9.8 and 12. We have one unknown side, which is y, and we simply solve for it. We have to state the formula. So it's c squared is equal to a squared plus b squared. Just a reminder, c squared, right? That's always the hypotenuse. And we know what the hypotenuse is. It's 12 squared. Is equal to a squared, b squared. It doesn't matter in which order you put it. So 9.8. So a squared plus 9.8. Note how I'm putting a bracket on 9.8. If I were to, if I were to do 9.8 and only square this, that's just going to give me 9.64, right? Because I'm only squaring this 8. But if I bracket the 9.8 and I square the whole thing, that's what I essentially need to do, because that's what the formula states. I have to take the whole number and square the whole thing. So don't do this, okay? Now we have, okay, so 144, that's 12 squared, is equal to a squared plus 9.8, and that being squared gives us 96.04. Now, I'm going to bring this 96.04 to the other side to allow everything to be equal to a. So 144, take 96.04 is equal to a squared, and bring this over here. And taking that away, that will give us 47.96. Now, to get rid of this squared, I'm going to have to square root 47.96, and that will give me 6.9 centimeters. Please don't forget your units. So, in that case, y is equal to 6.9 centimeters.